What's up? I'm Austin Griffith. I'm here with Simone from the Graph, and we're checking out a starter kit. Let's dive right into it, right? Let's get these containers up and running. But it's kind of like a Ethereum dev starter kit, right? With kind of graph powered. Is that how you would explain it?
Exactly. Yeah, it's playing around with all the technologies that the graph has. It's running a graph node locally, deploying a subgraph, but then also using the Guild's graph client to query that, and even we can even look into how to extend then the client side GraphQL schema, which is quite exciting in my opinion. And thanks for having me.
Yeah, heck yeah. And this is right up my alley because it's similar to Scaffold ETH. I've already seen how you were doing some PNPN stuff and bringing in multiple workspaces. But we were also saying that you have Docker, and being able to have Docker means that you can have all this stuff containerized, and so many other things can come up. Like you could be running an RPC node or a block explorer or something. There's so many neat things you can do with Docker.
Exactly.
So yeah, take us away. Is
exactly.
So here's the repo. I'll put this repo in the show notes also. Yeah, hackathon starter kit. Awesome.
All right. Cool. So I have it already here cloned. So basically what you need to do is just pnpm, which is the new kid on the block next to yarn and npm, right? Def, which spins up a local hard hat node. So you can deploy your contract, a local graph node together with a Postgres database and IPFS, and and that's it. And so you can just get started. You can think about to extend this actually with also having Next.js and run directly in this Docker Compose.
Your web server or whatever. Yeah, your dev server. Yep. Or like I said earlier, like a block explorer if you wanted like a local like Tenderly or something like that. Yeah, a lot of cool stuff could go in here. Yep.
Yeah, I looked at there is this one open source. What's the name?
Block Scout maybe.
Yes,
I'd love to see a Block Scout Docker container. I tried to make one a long time, like two years ago, but I bet there's something better out now. Sorry to interrupt.
No worries, because I was looking at Block Scout and tried to run it as a Docker container, but I mean I invested 10 minutes and then I failed.
I made a Docker container for Block Scout like so many years ago, but I'm sure it doesn't work anymore. I would love to see one now. I might put that on my list.
All right, so the next command just to have a quick start is pnpm quick start. Which basically deploys the contracts that we have to the local graph head node, and then deploys the subgraph to the local graph node and mints one transaction. In this example, I use NFTs because NFTs are cool and everybody understands what's going on.
So it deploys an NFT contract also, and then calls a mint function on the NFT contract. Is that right?
Exactly.
Awesome.
And so like, how long are we in here now? 1 minute?
Yeah,
so in 1 minute, you have a fully local development environment powered by the graph and local hard hat node. And then you already see I have the mints, right? So the cool thing about the GraphQL Explorer that's now baked into the graph node is that we have on the left side the Explorer. So we can explore what entities are here and start to, just go in and click some stuff and see what's coming out. And
what about like tinkering on the smart contract? Like, would you add something to the smart contract and then redeploy and kind of get into this loop where now you go tinker with the front end? Yeah, let's look at the smart contract here.
Yeah, that's a good question.
Awesome.
So this is,
super simple.
Super simple. We can say,
yeah, let's throw a new event in. Love this.
Let's just have a new event, which is mint. Perfect. I mean, mint. Sure. All right. And so that's now, here comes the idea of so-called no-code subgraphs. A lot of people are afraid of subgraphs because when you get started with development in Web3, I mean, most people maybe already know a little bit JavaScript and stuff, but then first like Solidity, shit, what is this? And then you end up maybe half your contract somehow working. And then people tell you like, yeah, but you need to use the graph. And then you look at the graph, it's like assembly script. Like, oh, what is this? And all the concepts with the WebAssembly and code stuff and like a schema. And it's just like, whoa. So that's why I think the idea of the no-code subgraph, and I'll show you how this goes. I need to work on this. So basically, you can just delete the subgraph folder. But then I need a small trick now. I think I need to just restore the networks. I can fix that, but it's just when I do now, again, PNPM quick start. I hope it works.
Rebuilds it based on, so it's going to compile and deploy the contract and then give you an ABI.
Yes.
And then from the ABI, it can make the subgraph.
The subgraph is recreated, but I need to do another quick cheat here, which is reset this.
I like this. This is raw. Like you're still like kind of just getting the starter kit together and finalizing how it's going to work. This is cool.
Yeah, it's very early, but I was like, yeah, I need to go out. Like I need to talk with people about it. Maybe.
Yeah.
I can motivate people to help. I mean, I'm not full-time working on this, so yeah. Okay, let's try again.
Please work second try.
So the problem is the auto generation. It has some assumptions which are different, but we can iron this out. It goes about the idea. So I just recreate. Oh my God, what's I need to go and do this quickly.
Get an installation.
Let's try a third time.
It's this is one of the best parts of the shill your stack sessions when someone comes on, is the raw when something doesn't work and how we troubleshoot through it. Give people, other developers that are watching some context about what to expect and how to get better at this stuff. Exactly. Awesome. So our subgraph is up now.
Because in the docs, it always works, right?
Right. If it works 100% of the time, it's not, yeah, it's not real life.
All right. Now, see, we added the mints.
Yeah.
So we see here also ID2 and we see the transfers. I mean, it's the same, but now as a dApp developer, I don't need to care about the subgraph. When the tooling is ironed out, then whatever you do in the contract, you just say like, boom, create me a new subgraph, and you don't need to care. It's just here. It's here for you.
And then, so this would translate over to your front end or something. You would kind of iron out what you want your query to look like, what kind of data you want in the state of your front end. You would craft it up here in the visual builder, and then it would basically give you a query that you could copy and paste into your front end, and then you'll have all this information. Cool.
So you would do something like, I've already prepared it. So you would do something like, there is also a front end folder, right? And
this is where you're using Next.js or something like that?
Yeah, exactly.
Cool.
And graph client. Let's look first at the magic and then explain what's behind it.
For sure. That's the way to go.
So what you need to do here, I need to cheat quickly. Yeah, I need to build the graph client first. So the graph client is built by the guild. It is a kind of client-side GraphQL magic thing that can stitch schemas together, so you can use it to query multiple subgraphs at the same time. Sushi uses that now in the new front end, but like there are a lot of projects are cross-chain. So that's one use case for the graph client, but there is also more beauty that I want to explore today that we can do. What we need to do is to just build the graph client, and then you can run PNPM dev. It's just the next project. Some error warnings, whatever.
The scaffold ETH at any given time has so many warnings in it. Awesome, we've got a front end.
Yeah, and we see here, we already have, we see the mint, right? The first one. Now, the first thing that's cool, in my opinion, is when we do PNPM mint. If you just mint the new one, boom, it auto updates.
The events are coming in. Yeah.
So why does this happen? There's a new feature that the guild is currently working on. It's called the live queries. Live queries, if you're familiar with GraphQL, it's just like you tell them like, hey, this query is actually live. So whenever the underlying data changes, I want to have my front end updated. This is the specification that will roll out into the graph node eventually. They're working on it, but the graph client already exists. So the cool thing is, with the graph client, we can try out new features that are in development before they actually land in the graph node. So it's kind of a sandbox, a playground. Yeah, and that's it. I mean, we can have, so what you would do is you have the query from before. We don't necessarily need the block number. It shouldn't be named transfers. And then you can work on your query here. Yes, but I want to also look into one thing, and that's where the custom resolvers, the custom front-end resolvers come into play. And this is where I think, like most of the front-ends currently use hooks, right? We transitioned from Redux to hooks, which is nice.
Shitload of RPC calls.
Yes.
Yeah.
and it also I think it makes the front end a mess eventually, because you have all these hooks, they are lying around, you don't know how they're interdependent with each other, like when is the data actually requested and when not. And then in my opinion, for complex application, you start to get into troublesome. So obviously I can just log in here with my MetaMask, and then it gets my address out. But let's see under the hood how this works. So I have here an account query that I have in Ethereum, like I can query for Ethereum and then account. And this actually is possible through client-side schema stitching and client-side resolvers. I explained this quickly how this works. So you can say I have a schema, and I start to extend it. And here I think also we go already into the direction of modularizing the front end. So with scaffold maybe 2.0, maybe at some point you think about like, hey, we want to have easy plug and play modules that come in that are in itself independent, do not have like much of requirements to the like parent module that requests it, but still have everything you need. And that's where this pattern comes in. So you can say like, I actually want to extend the schema and I want to add a mutation. And then you can define the mutation type. So there is a connect. So we were able to run a connect mutation. We can look at this in.
So in the graph schema or in the graph config, we're kind of configuring or setting up what our front end state needs to be, or some kind of front end state with mutations.
Exactly.
And you're setting that kind of schema up in your config, and instead of using a bunch of hooks to pull kind of independently, it's kind of this hitting this middleware layer and keeping that state populated live. That's
exactly
cool.
I would say in a modern non-decentralized application, what you usually have is one GraphQL server that serves you everything that you need, and that has mutations, subscriptions, and queries inside. But obviously with depths, we do not have a server. The graph kind of wants to be that server eventually, but currently it doesn't work for everything, especially mutations or account level stuff. Obviously, that does the graph know nothing about. So we can already start to use the same magic. So we think like this, what we previously would have as a server running in the server, we just move it into the client, but the layer stays abstracted from the user interface. So we kind of have a mini server in the front end that is plug and playable.
So you're running a container locally that will basically represent what the graph will be in a decentralized form eventually. Is that saying the same thing? Okay,
yeah,
cool.
Yeah. But you can also enhance it with whatever you want. So we saw, so for example, the connect goes to use mutation. Use mutation is the standard from Oracle. It's the same with Apollo. I can go into the connect. Actually, that's auto-generated. So we see the mutations here. So it's just like very small. You see, it's very small, like the connect mutation. It's nothing big. But when I'm running it, then it goes through that mutation. it will go in here, see like, hey, here we have this connect mutation, it's actually here. And then also we have additional resolvers, and everybody that already wrote the graphical server knows what resolvers are. It's the code that runs when you query a field in your GraphQL schema. And that's cool. So we have resolvers here, and we can look into the connect resolver, which is really simple, doing ethers, get the provider, request accounts, then just sets it. That's it. Like, it's not super crazy. And on the other hand side, we have that's the mutation. So we have the query, which extends Ethereum. I think that could be nicer, but I don't know. I need to work on this. But in the end, you have account. So if you run the account query here, it will go in here and does, like, again, with ethers, what we know, like try to get the address. If it has the address, it returns the address. If not, then returns undefined. So we could think about extending this in a lot of ways, right? We could say, like, for account, you have ERC20 balances, you have NFT balances, you have maybe you want to have ether balances, you want to maybe probably see your recent transactions. Like, there's
all
a lot
the
of
things you're using hooks for. Yeah, just look at like the WAGMI hooks library or ETH hooks and Scaffold ETH. All of those hooks you'd code in here basically and have it part of this kind of resolver thing.
What you end up with is like a very nice separation of concerns. So you can have a front end that is not concerned about the data loading, data, where is it coming from, all the race conditions that you run into. And also it would be extendable. So you could say, like, okay, I wanna load let's say I want to load the ERC21 that would look something like Ethereum account string. Then it would be something like ERC20. You write just here, that will be a number, and then you write the resolver. That is here, that would be 20, blah, blah, blah. I don't
feel it. Like create a contract object and do a read on the contract object to get the value or something like that.
Or you can bake in another subgraph.
Okay, yeah.
So for the NFTs, you could query the NFT holding subgraph, and that is all abstracted away from the actual front end or UI engineer that just interacts with the graphical schema. Now it gets even a bit better. That, however, our schema actually looks. We need to stop this. So maybe it's a bit hard to wrap your head around, like what is loaded, how is this schema now extended or not, and that helps. So we have this graph client serve command, and that could also run, if I would like work more on the Docker Compose file, that could also run separately from the front end. So you would have it already up and running, but yeah, it's work in progress. So the cool thing is the graph client, the development, what's the name? Development serve dev, it exposes you everything here again. And see, compared to this one, I only have meta here. That's the one directly on the graph node, but this is the extended. So I see Ethereum. And because we added ERC20 before, it also has, I don't know.
Fake.
I know
but we
happens.
Have the stuff in there. Yeah, exactly.
Nothing.
Okay. So as you add those things in here, they show up in your query toolbox. Cool.
And see, this is now server-side generated. This is by Windows not defined, but it's okay. I mean, like, it's good enough for me to explore the schema and however it is set up, and to get the query out and then bring it over to the front end and build on top of it.
I talk a lot about forkability of projects, where yes, you're building a cool project and it's open source, but how forkable is it? Could someone take it and make a small change to it? With the separation of concerns here, where you have your state loading in one kind of silo, and then you have your state display in another. If someone doesn't like the way it looks, they could fork this really easily and have the same state and just change the way it looks without having to deal with, like you said, the race conditions of all the different hooks that have to get all that different data from all the different places at once. and wait for it. Yeah. So is there a longer wait time? Like knowing that if I was thinking, okay, so imagine there's a layer of abstraction on top of all of these hooks and you're getting all this information. Are you kind of waiting for the weakest link? Like, is it still fast? I guess is my question in the middle.
Yeah, that's the beauty about GraphQL, that you only trigger the resolvers that you are actually triggering. So when I'm just here, for example, check for the current block number and hash, whatever, I get them, and the code inside of the account is never run. So GraphQL actually is, in that regard, in my opinion, very well suited for exactly this, that when you write obviously you can overfetch, and you can, with every query, you can send this in. This actually can get dangerous because account might be slow. And if you always query it despite actually needing it, yeah, but the optimization is easy. Do not overfetch. Yeah, that's it. And then you have it.
So let's say we built a little token or NFT. We set up a little front end that lets you mint it, and maybe we displayed all the different mints. And we've got it on localhost working. Maybe we deploy it to a test net for a little bit, but what happens here in terms of going to production, or in terms of like getting it out there for someone else to play around with? Once you have it all locally, there's a lot of containers and infra we have up. How do you move that to the cloud or whatever, or move that to being backed by a real subgraph or whatever?
Yeah, that's a good question. So, so for the contracts, it's hard hat. So what you would
just
would
deploy
do is
them. Yeah,
you go in here and you add your chains that you want to deploy. And so that's the easy part. The subgraph is also, I mean, quite straightforward. I mean, I could just now go to, like assuming we are using Girly, I can go to Subgraph Studio when it loads.
Okay, you would take that query from your front end that you figured out, and you'd put it into Subgraph Studio or some web app, and that would let you create. There we go. Okay, cool.
Yeah, I do Girly. What is it? My
NFT or some NFT or something like that. Yeah.
NFT. Then it's available. My NFT. Continue, and then it's this one. Boom.
Cool. So
yeah,
you
it's
from the
localhost.
front end, you authorized your CLI, and then you run something in your CLI that deploys it up to this backend or whatever, this graph node or whatever.
Yeah, the graph, Subgraph Studio.
Subgraph Studio.
So yeah, there's some front end steps that you need to do, but I mean, same would be with the front end, right?
Right, and if it's Next.js, you're going to build and deploy some static app to Vercel or wherever you're deploying to. So there's hard hat, and the local environment comes with a handful of things, but it starts with probably hard hat, and that's where you're deploying and you're getting artifacts from that. And there's another container that's like a subgraph, and your artifacts are injected into that. And then there's all the way kind of to the front end. There's the Next.js stuff, and the Next.js could be deployed to the web. What's the middle part? Is there another container in the middle there for? That's it. It's just Next.js dev server, the subgraph server, and the hard hat node.
Exactly.
And those are basically your main pieces. And each one of those, if you're familiar with them, it's just the steps. You're just kind of wiring them all together as kind of a coherent starter kit here.
Exactly. I mean,
cool.
There are two ways. So like the graph client can be also statically built. So I mean, like I'm a decentralization maximalist, or an eventual decentralization maximalist. I understand that's not always possible right now, but still, like that's for me a guiding principle. Like it should always be possible, or we should always try to go in that direction. So with graph client, the thing is that it can be built directly in your static build, and like your whole front end can just be uploaded to IPFS. That's it, right? So, but if you really want to, you can also deploy some sort of server or cloud,
like middleware caching layer kind of, or server host. Yeah.
If you want, but I don't see like a big advantage out of it, because like the real magic happens when you run the graph the GraphQL stuff in the front end, because then you have access to MetaMask or the injector provider, and you could build much more out of it. Then if you would put it into a Cloudflare, whatever thing, then you do not have access to that. And that's actually no real additional value, in my opinion. Yeah, and then
okay, yeah, that's an extra part here, is the subgraph stuff is pushed to the front end where the wallet is, and other things that you're going to be interfacing with. Okay,
exactly.
Interesting. Cool. Awesome. And for people to get started, they basically go to the repo and start forking it. There were some magic steps that you did along the way that I'm guessing will slowly be kind of ironed out as you finish this off. But is this the place to go? Oh, cool. This is a good looking repo.
Yeah, I mean, it's easy. So yeah, so this works, the quick start, and you already have like the contracts up and running at the graph node, local hard hat node. That should more or less work. I heard that like you need to be careful that you really use the latest PNPM version. There are some additional steps. Maybe I should implement this. Yeah, but then you can follow these steps. And yeah, I mean, like I'm open for issues, pull requests, ideas, anything. I mean, as I said, like I do not have like a lot of time to work on this. It's more like a little bit of a pet project, you know, also play around with the graph, if the latest graph node releases, latest graph client releases. So there is like this intrinsic motivation, or like, but I think these are patterns that might emerge at some point into the next wave of dApp architecture, or hopefully, or I don't know, maybe I can inspire some people.
Yeah, exactly. That's what you just have to kind of like build a few things with it and show it off, I think. And that's what we're kind of doing here. And let's see if more people extend it. I'll put a link to this in this video too. So if people find this kind of YouTube searching, they'll get a good link to the GitHub and start building. Thanks, Simone, for showing it off. That's really awesome.
Yeah,
thanks for showing off, man. Yeah. See you.